Okay, this video is related to your submissions for Program 10. First, we're going to briefly talk about comments I had when I was going through grading your programs. Then I will discuss the Prisoner's Dilemma contest, starting with the code that I used to actually run the contest, and then we'll look at the results of the contest, including which students got extra points based on their Prisoner's Dilemma strategy. So, like I said, first the comments. At least one student literally put your name for their name. Of course, that should have been name, and in my case, like Wayne Beach. A few students' descriptions had more than 40 characters. There's a reason that I limited it to 40 characters, which we will see when we talk about the code, and probably more so when we actually look at the output of my contest driver program. A few students tried to use the pound bang notation, which is a good thing, but they put like the description of the program and the standard header and then put the pound bang. Again, the pound bang notation will only work if the pound and the exclamation point are literally the first two characters in the file. So even if you put new line, a blank line, pound, exclamation point, it will not be acknowledged because it in that case is the second and third character in the file as opposed to the first and second. Another comment, some people copy and pasted their output from the server, which is a good thing. I've been telling people I don't want screen grabs. They're hard to read, and if I need to debug or something, I need to be able to copy and paste your program or sections of your program. But some people did not copy and paste the commands that were actually being executed. So I couldn't do things like verify the right version of Python is running, the location of your program, and things like that. Another thing that you're supposed to learn in programming classes is programming to specifications. You know, if you are told that a function has to have a certain name, then make sure you use that name. If you're told that your function is supposed to have 3 arguments, make sure you write it to have 3 arguments and in the order specified, you know, in the specifications. So programming to specifications is one of the things that you should be learning in addition to, the language that you're learning, in our case, Python. So at least one student did not put their name or description lines in their header at all. And I need to pull that information to run the contest. So I've gone through and I've graded the assignments that were submitted on time. I did not add the extra points in your Blackboard grade book yet because I didn't want to run the fun and surprise of the contest. Now, I did this for many semesters in my Perl programming class, and the last class or second to last class is when we would be having this lecture. And this was one of the favorite lectures of the students, and we had fun running the contest. People wanted to know who did better. I had students that said my only goal in this contest is to do better than Sam. So people would joke around. I'd ask people who they thought who thought they were going to score high, which is the lowest number of years in prison, or who wasn't going to do so well. So people would raise their hands, and a lot of times people thought they did horrible and they would end up getting some of the extra points. There were some people, it's like, I'm sure I have the best strategy, and they would come out down towards the bottom. So it was just a fun conversation to have. So I'm going to go through the same material, but I don't know if it'll be quite the same, doing this in just a video recording. So this is how I graded program submissions. So, I'd go through student by student, and, I'd take, for example, the first student, and I would look at what they submitted. I would look at their test cases, I would look at the code, I would look at the output of the program, and make sure that the program met the specifications of the actual assignment. And then, you received a score 0 to 100 based on how you did on the programming assignment. Then what I would do next is I would pull your Prisoner's Dilemma subroutine out, and I would put it in a directory where I'm running this contest. I would give it a specific name, which for student programs is PD and initials. If I have a conflict with students that have the same first and last initial, which I did have one this time, I would do like PD initials and then the number 2, a sequencing digit onto the end so that it was unique. And then I would run the contest driver, and hopefully it would run and give me results. And if that's the case, I know your subroutine was written correctly, I know you put the name and description on it, and all that type of thing. Now, if an error occurred, and the error might be because you put some things in your driver program that really should have been put in your Prisoner's Dilemma subroutine, that type of thing, I would get an error, and most likely that error is due to the last student's program who I graded. So I would go in and look and see how big a deal it was. If it was a formatting thing, like your description was 80 characters, I would chop it down so it was less than 40. If I actually got a runtime error, then I would look at what was causing that error. If it was something simple, I would fix it. I think there was one case where there was just way too much stuff to fix, and that student still got a good grade on their submission because it did run correctly, but I had to exclude them from the competition because it was just going to be too hard to fix and take a while to figure out why it wasn't working correctly. So next, what I want to do is I have a programmer called driver.py that I use to run the contest, and what I'm going to do here is, by the time you're watching this, there should be a video inserted that's talking about my driver program. Okay, here I have my contest driver program in a text edit window. You can see up here at the top that I simply named it driver.py. So what I want to do is go through and discuss part of this. First thing, of course, up here at the top is we have the pound bang notation, which ensures that if I run this as an executable, that it's going to use Python 3.11 to process the program. I then have a minimal header telling that this is my Prisoner's Dilemma contest driver. Next, I import some of the libraries that I'm going to be using. The glob library is for using wildcards to list out, for example, files on the system, which is what I'm going to be using it for. I then use RE, which is for regular expressions, because I need to do things like find your subroutine name and replace it with player whatever. And then I import subprocess, which you have used before to get output from a Unix command. So basically what this program is going to do is it's going to write another program and run it, and then it will write another program and run it. So it's going to generate an executable, which is called play2.py. So what will happen is when player 00 is playing player 01, for an example, it will put player 00's code in the file, it'll put player 01's code in the file, and then it'll put a little driver to do the match between those two players. Now, num times is how many times I want to run each person's subroutine against the other subroutine. So I chose 200. Next, I have a function called doMatch, and what doMatch does is it writes out, like I said, a small program to run a match between two players. So the arguments to this is player, what I'm calling P1, which is the first player, P2, which is the second player, and then a number n, which is how many times I want them to play each other. So I open up my temporary file, which is called play2.py. I open it for write. The first thing I do is I write the pound bang notation again, so that I ensure that Python 3.11 is what's running this. I then have code for the two players, so I output player 1's code, player 2's code, and then I print out several lines here. So this main program is the main program for one match. And then what I do is I go through and I write out code. So I'm going to set num match equal to whatever n was passed in. I'm going to initialize some things, how many years the people got, and their moves. And then for I in the range of num match, so in this case it would be I 0 to 199 to make sure that I ran these against each other. So what I do is I have results, and what I do is my result for R1 is player 1's subroutine name, and then in parentheses previous moves that player 2 did. And conversely, the result for the second player is their subroutine passed in with whatever the history is for player 1. So that's what the H is for, history. So then I just hard-coded my years here instead of doing a subroutine. So I have R1 and R2, which are the results of the current iteration, and then I apply this, and if they both testify, I add 4 years to both of their sentence, etc. And then down here I have an else that says error, we should never see this. And this might happen if there is a bug in a student's prisoner dilemma subroutine. I've seen things before where somebody would generate a number between 0 and 0.9999, and then they would say if it's less than 0.5, hold out, if it's greater than 0.5, testify, which, listening to that, sounds like a reasonable thing. But the problem is if the random number generator happens to return exactly 0.5, no value would be returned, and that would result in that else condition or else block being executed. So I would go back, look at the student's program, and figure out what they did. And in that case, I would change it, one of them, like I might change the less than to less than or equal. And in that case, it would handle everything. And then I take the current move for each player and append it to their history list. And then I print out how many years player 1 got and how many years player 2 got. And then I close that file. I then go through and use popen to execute that play2.py temporary file, and then I want to grab the output. So I read the standard out, I decode it into ASCII, and then I take the result, which will be 2 numbers, I split those apart, and then I return how many years player 1 got and how many years player 2 got back to the main program. Here is a function to play 2 people. So I pass in player 1, player 2, and the number of years, and this is where my output is going to come from. I'm going to print out, that player 0, 0 versus player 0, 1, for example. I'm going to do the match between those two. I'm going to take the result that I broke apart as a result of do match, and I'm going to make sure those are integers. And then if both of those come back as 0, something went wrong. For some reason my program didn't turn out any output. What I'm then going to do is I'm going to do a formatted print to print at the end of that. I already have player 0 versus player 0, 1, and then I'm going to print out how many years player 1 got, comma, how many years player 2 got, and then I'm going to add that to my years dictionary or list that's keeping track of how many years each of these different people got. Now, down here is my actual main program for the driver contest. So I initialize some dictionaries to be empty so that I know they exist. And then what I do in the current directory, I use this glob.glob PD star. So what that's going to do is basically the asterisk at the Unix command line means the same thing that it means in regular expression, 0 or more characters. So instead of being a quantifier right there at that point, it literally means 0 or more characters. So I'm looking for files in the current directory that start with PD and then have something after them. So that's just a naming convention I came up with. I then use the length function to find out how many subroutines I have. If my subroutines, I don't have any, that is num subs is 0, I'm going to quit the program, printing out there's no subroutines found. If the subroutines equals 1, then I'm going to print out a message that says, hey, I only found 1 subroutine. For there to be a contest, there has to be at least 2. And then if I make it past these 2 conditions, I'm going to print out how many subroutines there are in the contest. I'm then going to set the player to 0, and for each of my subroutines, I'm going to print out the one I'm processing, and then I'm going to initialize the current name, the current description, and the current subroutine name to empty strings. So I'm going to open one of your prisoner dilemma files, and then while I don't have the name, description, and subroutine name, I'm going to process lines from the file, because presumably these are at the top, and once I find all 3, there's no reason to continue going through reading these. So, if I find line colon, I'm going to read the name of the student. If I find DESC colon, I'm going to read your description. Next, if I find the define keyword with possible white space and some word characters, then I have the subroutine. So I'm going to pull the first match out, which would be here after the DEF. So here's my back reference that is getting the subroutine name, and I'm going to eliminate any white space around it, and then I'm going to print out what the function name is. And then once I'm done, I can close that file. I then do a format string, an F string. Notice that it's not inside a print, so I'm actually using it to construct a formatted string that has the word player followed by the player number in 2 decimal digits. So the first time it'll be player 00, the next time it'll be player 01, etc. And then I'm going to output to the user what player number was assigned. I'm then going to store the name and description in my dictionary, and then I'm going to set the years equal to 0, because when I start out, everybody's years in prison is 0, and as I go through and play matches, I would go through and do that. Now, just to mention it, Perl and Python are very similar. I was converting my Perl Prisoner's Dilemma contest driver program to Python, and I left this in here as I was going through doing this. In Perl, I can put in backticks, which are what these are called. I can put a Unix command within backticks, and this basically says cat out the user's subroutine, use the stream editor to substitute for their subroutine name their player string. So this was a tad easier in Perl. What I had to do in Python is I had to use the subprocess pipe open to basically do the same thing. Then I had to grab standard out. And then what I have here as subcode when I convert it to ASCII is I have the player subroutine with the subroutine name replaced with their player string. And then I move on to the next player. So I increment my loop variable player by 1. So then what I do is I print out that I will play each subroutine against each other subroutine num times time. So in this case 200 times. I print out a little header that says I'm playing matches. I sort the players ultimately by numeric order by their playing number, although it is really sorting alphabetically. That's why I have 2 digits there, is so that it will sort correctly. And then while I have players left, I'm going to pop one player off. So the first time it'll pop off player 00. The 0 means from the beginning of the list. And I'm going to, for all the other players, play the current player against another player num times times. So I have a while loop that's going to go through and play all the matches. Once all the matches are played, I print out the results. I sort using a lambda function. So I sort based on the number of years. I print out my headers for my results, and then while I have rankings, pop off the ranking, and for that player write their number of years they got, their subroutine name, and a description of what they're doing. And then that ends the contest and tells me from the least number of years in prison to the greatest number of years in prison. Okay, I then took my driver program and ran it. So I ran the contest, and the way I did that was I ran my driver.py program, and I redirected the output to output.fall 2023. So my program ran for a few seconds. That was running everybody's submission against every other submission that I had, including some standard solutions to Prisoner's Dilemma. So that's how I ran the contest. Now let's go through and look at the output file. So the very first thing my code does is it goes and looks in my Prisoner's Dilemma folder where I run the contest. It gets all the files that start with PD, and then in this case it says there were 16 of those, and then it goes through and processes each of those 16. And what it does is the first one it found is PD web standard WTDL.py. So the PD means it's a Prisoner's Dilemma subroutine. The web are my initials, so it's something I wrote. And this is a standard routine, and the WTDL stands for what they did last time. So I'm just going to look at their last move and do that on the next thing. I then find the function name that I used. In this case it was dilemma, and I assign myself player 0 because this is the first file that I'm looking at. And what I do is I replace the function name dilemma with player 00. And then it continues on. Next we have a student submission here. In class I run the program in class and then discuss it when I have an in-person class, and you would actually see the name here so that the students could have some fun and joke around. But since this is a recording, I decided to blank out the names. But this person's description was tit for tat, and they were assigned player 01. Next we have one of my attempts, and it's called good 1, and this was one of my submissions where I was seriously trying to do this. So usually the best way to win Prisoner's Dilemma is to figure out what your opponent is doing and do the exact same thing. So if you both testify against each other, you get 4 years instead of 5, and if you both hold out, then you get 2 instead of 5. And in this case my solution was assigned player 02. Next we have another student subroutine. They held out on their first move and then testified until they had 4 moves, and then I can't remember what they did after that, but they were assigned player 03. Next is one of mine that alternates between holding and testifying, and it starts with a hold. Next we have another student do the opposite of what they did last time. So that would work really well against my alternating one that I just talked about. But they were assigned player 05. Player 06 is one of mine that generates a random number and then testifies 2/3 of the time. I then had an alternating one that was kind of like the one before, but instead of starting with holding out, I started with testify. Next is one of mine, testify if they're holding out 2/3 of the time. So the strategy there is it looks like they're holding out. So if I testify, I get 0 years and they get 4. So, it's kind of playing the odds a little based on what they've done in the past. I have one that I call nice guy, and what I do is I always hold out. I'm never going to rat my opponent out, and that was assigned player 9. Next, we have another student 1. It says hold out if the friend has for the past 2 moves. And this student was assigned player 10. Here's one of mine that I testify 1/3 of the time, followed by a student's that they called mirror strategy, which was assigned player 12. Another student routine called alternate each move. They were assigned player 13. Another student's one who used their name in the description, so that's why that's blocked out. But basically it was called Wild Random Rumble, and this student was assigned player 14. And then since we started at 0, player 00, the last one of course is player 15, and do one that they have chosen the least. So if they testify the least, you're going to testify against them. And their function was called calc_move, but that was replaced with their player 15 assigned player number. So that's the first part of the program, going through doing that. I now have a variable in the program that tells how many times I'm going to run the matches against each other. And in this case, that was set to 200. So it tells me I'm going to run every subroutine against every other subroutine 200 times. So I pull player 00 off, and then I play them against every other player, telling how many years in prison each person got. And then continuing on, I deleted 12 lines here, but I wanted to show you the transition. Player 00 will play player 15, and then player 00 is done. So we move on to player 1. Well, player 1 has already played player 0, so they start out playing player 2, player 3, etc. So this goes on, running all the matches. Here I deleted 210 lines so I could show you the end. 12 finishes up all the other players. When 13 comes around, they only need to do player 14 and 15. And then player 14 just needs to play player 15 because they've already played everybody else. So it goes through and runs the contest, and again tells how many years the first player and the second player got. It then prints out the results, and the results are years, name, and description. Of course, the years are from least years in prison to most years in prison, because the way you win Prisoner's Dilemma is by getting the least number of years in prison. So I print out the total number of years, which is going to be big because I ran it against each other 200 times, and potentially out of 200 runs, if you do really, really bad, you can get 1,000 years in prison. I printed out the subroutine name, which is player 00, player 01, for example. And then here's why I limited your description to 40 characters, because I wanted to output it nicely in the results. So the first line of output is player 03, and they won by only getting 5,703 years in prison. And this is actually a student subroutine. So the person whose subroutine this is will be receiving 50 extra points on the assignment for first place. The next person was player 2. I believe that was one of mine. And then another one of mine, which was testify 2/3 of the time. Next, we had another one of mine, which was testify if they are holding 2/3 of the time. And then next is player 14, which is actually a student subroutine, and they came in second place as far as people who are currently enrolled in the class. So player 14 will be getting 40 extra points on their assignment. Next, we had one of mine, which is alternating, starting with testifying. Then we have another student one, player 05, which is do the opposite of what they did last time. So whoever's subroutine was player 05 will be getting 30 extra points on this assignment. Next, we had tit for tat, which is another student assignment. And since this is fourth place as far as current students enrolled in the class, player 01 will be getting 20 extra points on this assignment. And then we continue on from there. Next is player 10, then player 00, then player 12, then player 13, then player 15, and then player 11, which I think is one of mine, player 04, which was one of mine. And then what I think is funny is over and over again, semester after semester, proof that nice guys finish last. So by holding out all the time, I ended up with almost 10,000 years in prison. That finishes up the discussion of comments I had related to grading program 10, the discussion of the code I wrote to run the Prisoner's Dilemma contest, and the results of running the Prisoner's Dilemma contest this semester.